Good morning, everybody. How are you? I miss you all, really. Today we're gonna to complete our lesson about geometric sequence. If I have a sequence like this, 1, 3, 9, 27, if you remember, we said that the first term, we call it A, and equals 1, and the second term, it means AR. What about R? R is the ratio between any two terms. If you divide 3 divide 1, it will be 3. 9 divide 3, it will be 3. So the ratio here equals 3. So T2 equal AR and T3 equal AR power 3. And the conclusion will be Tn equal A power n minus 1. The power here decrease 1 than the power here. So here I have an exercise. He asks you have a geometric sequence and T5 equal 8T2. And I have here T4 plus T6 equal to 140. He asks you to find the sequence. Here he asks you to find the sequence. In this case, I will translate this one. T5 equals AR power 4 equals 8AR. If I cancel AR from here with AR from here, it will be R power 3 equals 2. Equals 8. So R equals 2. I will go, this is the first equation and this is the second one. I will substitute in the second one. Here, I translated AR power 3 plus AR power 5. Equal to 140. Instead of R, I will put 2. So 2 power 3, it will be 8A plus 2 power 5, it will be 32A equals to 140. So here 40A equal to 140. So A equal to 140 divided by 4, it will be 6. In this case, the sequence will be, the geometric sequence will be, I start with 6, the first term, I multiply it by 2, it will be 12, it will be multiplied by 2, 24, and so on. Okay? Now, we go to another part, we call it the geometric mean. We took before the arithmetic mean. We said that if I have 3 consecutive numbers, A and B and C, here in the arithmetic mean equals B equals A plus C over 2. This is the arithmetic mean. Just to remember. But here, if I have 3 consecutive terms in a geometric sequence, so here B over A equals C over B. From here, if I make cross multiplication, it will be B square equal AC, so B equal positive or negative square root of AC. This is the geometric mean. What about the question here? How can I find it? This is the example. He said to you that find geometric means of the sequence 4, and they have 1, 2, 3, 4, 5, 6. I have here how many terms in this sequence? I have 7 terms. The first and the last, and I have 5 means in the middle. I have 5 means in the middle. He needs the means. So n here equals 7. In this case, I must write the rule of the last term. The last term, here, R power of n minus 1 equal 2916. Okay, here I want to find R. If I find R, I can complete the sequence. I can find my means. So here A equals 4, and I have here R, I don't know it, N 7 minus 1, it will be 6, 2960. So here R power of 6 equal to 2916 divided by 4. You can use your calculator to find it. 729. So R equal, I have an even power. So the result will be positive or negative square root of 726th root, sorry, the 6th root of 729. It will be positive or negative 3. So here I have 2r, not 1r. So I have two geometric sequences. I have two sequences. So I have 5 means in the first one and 5 means in the second one. Here, the first sequence equals 4. If I multiply it by 3, it will be 12, 36, 108. Multiply 3, 324. Multiply 3, 972. And the last one is 2916. So this is the means. This is the 5 means that I need. Okay? Take care. If he asks you about the means, this only. The second sequence, it will be 4, negative 12, 36, negative 108, 324, negative 972, and 2960. This is the means. He asks you about the means. This is the means. So here I have two groups of the means. Okay? Now we will start another part. He asks you what is the relation between the arithmetic and geometric mean. If I have any two different positive real numbers, then you must know that the arithmetic mean, it means arithmetic mean is greater than the geometric mean. The arithmetic mean is greater than the geometric mean. This is a very, very important note because there is a lot of exercises about this part. For example, he said to you that if you have x and y, if you have here x and y and z and l are positive terms in a sequence, and he asks you to find this relation or prove this relation, x plus l bigger than y plus z. In this case, I will say that if they are terms in a sequence, then I have x and z and between them y. This is the geometric mean. If I want to find the arithmetic mean of x and z, x plus z over 2. This is the arithmetic mean. It's bigger than the geometric mean, bigger than y. So from this one, x plus z bigger than 2y. And I leave it as a first one. And from here, y plus l over 2 bigger than z. From here, y, l, and between them z. Okay, so y plus l bigger than 2z. This is number 2. By adding 1 and 2, I get here x plus z plus y plus l bigger than 2y plus 2z. Okay? If I cancel 1 from y from here and 1 from here, 1z from here and 1z from here, so x plus l bigger than y plus z. And this is the relation he wanted by using this note. So this note is very important. Okay. Now we go to talk about geometric series. We said before that the series is the summation of the sequence. The series is the summation of the sequence. So here, he gave you two rules to use them to find the summation of any sequence. So here, we take two rules, if you remember, in the arithmetic sequence. And now we will take two rules for the geometric sequence. Sn equals A multiplied by 1 minus r power of n over 1 minus r. Here, if I know r and a, the sequence. And another rule, Sn equal a minus lr over 1 minus r if I have the first term and the last term. Okay, if he gives you, for example, a equals 3 and r equals 2 and n equals 8 and ask you to find the sum. This is the sum of 8 terms. The sum of 8 terms. So S8 equals a here is 3 and 1 minus r 2 power of 8 over 1 minus r. It means 1 minus 2. It will be, by using calculator, 765. Please, you must differentiate between T8 and S8. T8, it means the 8th term, but S8, it means the sum of the first 8 terms. The sum of the first 8 terms. Okay? Okay. We'll go to another exercise. If I say for you, find summation from r equals 5 to 12, 3 to r minus 1. In this case, summation notation rule, you took it before. This is the series. It's a series. But here we start from the r equal 5. It means we start from the 5th term. It means T5 is the starting point here. Instead of r, I will put 5. It will be 3 multiplied by 2. 5 minus 1, it means 2 power 4. It will be 48. This is the first term for us now. So this is A. And T12, when I put, instead of R, I will put 12. It will be 3 multiply 2 power of 12 minus 1. It will be 6,144. So here, this is the last term here. So I can use the rule Sn equals A minus LR over 1 minus R. It will be 48 minus 6,144 multiplied by 2 over 1 minus 2. It will be 12,240. We have another solution. If we say here n equals, I won't use the first rule, not the second one. N, number of terms here. Some people said 12 minus 5, it will be 7. No. If you say 12 minus 5 equals 7, it means that you didn't take the fifth term with you. It means you take the terms between the fifth and the 12. So here n equals 12 minus 5 plus 1. This one, it means I will take the fifth term with me. I start from the fifth term. It will be 12 minus 5 plus 1. It will be 8. So here I will S8 equals a multiply 1 minus r power of n over 1 minus r equals 48 multiplied by 1 minus 2 power of 8 over 1 minus 2. It will be 12,240. It's the same result, and the rule is different. Okay, everybody, this is our lesson today, and this is handout 6. Please look at this handout and try to make the homework and try to be happy.